Hi, everybody. This is your sixth video for PSI 232. Here we're going to do two things. The first is something that we previewed in class on Thursday. That's Thursday, September 26th. If you have notes, you might know this already, and that is talking about types of objects in R. The second thing we're going to do, I'm going to switch over to Keynote, and you can close RStudio after that. This is a more conceptual discussion of different types of variables that we see in political science. Later on in the quarter, we'll talk about why different kinds of variables get different kinds of analysis. But for now, and for this coming Thursday's quiz, what I need you to do is learn the types of variables. So yeah, that's not so hard. We did that on the first day. Okay, first thing, types of objects in R. So as I said, we did some of this in class already. You can see on my screen that I've got RStudio open. Hopefully you can all read it. And I'm just going to review with you some of the types of objects that we've seen so far. The first is what we would call a variable or a value, right? So x is equal to 1. Oops, can't see that. Gotta pull this down. There it is in the environment, x being equal to 1. Another thing that a variable with a single value is a vector of length 1. A vector is any one-dimensional, that is like a string, a list of values. So they could be numerical, they could be character, they could be anything you want. So we could say x is equal to, remember the fabulous function c? Yes, of course you do. C is what's telling R you want a collection, that's how I remember it, of values. So 1, 2, 3, 4, 5. Hooray, we've made x into a vector of length 5. But we could also make x into a vector of length 5 by saying, x is equal to C, Amelia, Henry, Watson, Jared, and Angela, who's our housemate. So now x is another vector of length 5, but this time it has character values. Okay, that's not so hard. It's a list of numbers. I should say that there's also a special R object called a list. Yeah, it's frustrating. A list is not quite the same as a vector because it can have multiple dimensions, but guess what? You don't have to worry about that for this class. If you run into problems, we can talk about it, but in general, you can think about a vector as a single list of numbers of any length. Okay, next kind of thing. The next kind of thing is what's called variously a table, a tibble, a data frame, a data set. This is the sort of thing that we made in class on the first day. So it's any collection of some number of observations where your observations might be people or families or cities or dogs or whatever, right? Your rows are observations and your columns are vectors. And that coughing you hear is my husband because I'm at home. That's how it works sometimes. So how do we make a data frame? Usually what we'll do to make a data frame is to import that data from elsewhere. And we've done that a little bit. We're going to start doing it quite a lot more with the function read_CSV, which always produces a tibble, which again is tidyverse's way of talking about tables and data frames. There are differences between these types of objects. So tables, tibbles, data frames, matrices are all things that R thinks of as slightly different from one another. Again, as with the distinction between vectors and lists, we're not going to deal with any of that. We're going to treat every data frame, every data set we look at is going to end up being a tibble for the purposes of analysis. So never fear. But if you'd like to know more about the differences between a table, a tibble, a matrix, a data frame, etc., please let me know in office hours, not in class. Okay, let's make a data frame a different way. Let's say that we have, we have a list of things, which is X, which is Amelia, Henry, Watson, Jared, Angelo. Those are 4 people and 1 dog who live in my house. Let's measure some characteristics of those people. Okay, but first, let's make a new variable name for x, because x isn't very descriptive. So instead of saying x gets that thing, I'm now going to say name gets x, right? Name gets x is roughly the same as saying name gets C, Amelia, Henry, Watson, Jared, Angelo, close parens, but much shorter. All right. See what I did there? I renamed the variable x, or rather, I copied the variable x into a new variable with the name. Sorry. Okay, what are the characteristics we'd like to measure? I'm going to go ahead and do age next. So for age, we're going to make a list, and it has to be in the same order as the list name, and it's going to get 38, 38, 3, 10, 39. Yep, I do know how old my spouse is. 28. Angelo is our housemate. He's younger and cooler than us. Okay, click. So now we have another variable, and we have another vector called age, and it has in the same order as the vector name these values, which are our ages in years. Okay, let's make another one called species. Yes, C. Right, we're going to gather up the values for each person. Now, everybody in our house, or at least everybody in this list of people in our house, is a human except for Watson, who's a dog. So we're going to code that like that. H, D, H, human, dog, human. Correct. All right. That seems like enough for a data set. Sound good? Great. So we're gonna say something like household gets, and we're going to use a new function. This isn't a function I'm going to test you on at any point, and it's not a function we're going to use much, but I'm using it today. cbind, which means, guess what? We're going to bind columns together. Name, age, species. All right. And now you see that in the environment pane on your right, under household went under data and not under values. And the reason for that is that we now have a sort of multidimensional data set. So if I go household like that, I end up with something like this. You can see that it's arranged in a table. What I'd really like to do is arrange it in a tibble. So I'm going to go library tidyverse and wait for that to load. Yep. And then I'm going to go household gets as underscore dibble household. All right. So what am I doing here? I'm taking household and I'm giving it a slightly new format. So previously household was a table or matrix, and now we're going to make household into a tibble, which is nicer in my opinion for analysis. Okay, now let's look at it again. When we type household this time, it says, hey, look, it's a tibble with dimensions 5 by 3. That's 5 rows by 3 columns of name, age, and species. So now we can refer, remembering back to lecture 5, where we learned about how to refer to columns in tables or columns in data frames, we can refer to each one of those columns using the $sign. So for example, if we wanted the mean age in years of the people that I have listed in this data set, I would say something like mean, remember how you do it, household, $sign, age. Let's see what happens. Oh no, that's an error message. Argument is not numeric or logical, returning NA. So rude. First then, we need to make household $age into a numeric variable. So household $age gets as numeric household age. And this is analogous to what we did a minute ago with turning household from one type of thing into a different type of thing. We're now telling R that we want to treat this variable called age as a number rather than as text. That's what we're doing. So as.numeric, and there are a lot of as functions. So as.numeric, but if we want to treat numbers as characters, we can go as.character. We can do all sorts of fun things. Anyway, now we've done that. And now when I say mean household $age, I get that. Which is not a very useful piece of information since, I don't know, who cares that the mean age is 23.6? But there you have it. Notably, when you take the mean of a vector such as household $age or the column age from the dataset household, you get a single value. What's a single value? It's a value or a variable. Yes? Yes. Okay. All right. The other two types of things that show up in R, the types of objects that we will be concerned with in this class, are models, which essentially are kind of packets of information derived from running statistical analyses of particular types. That sounds super abstract, and I invite you to forget about it for the next 5 weeks. But just keep in mind that a model object is a particular thing in R. Second and last is graphical objects, so plots usually. We did a little bit in previous lectures with histograms. A histogram is a type of plot object, so I can, for example, say hist household age. Oh no, there's an error that I don't see that often because usually my screen is zoomed further out than this. There it is. The problem that RStudio was having is that there wasn't enough space for it to make this histogram. But you can see we've made kind of a meaningless graph of the distribution of ages in our household. So here from 0 to 10 is my son Henry, who's 3, and my 10-year-old dog. Nobody from 10 to 20, from 20 to 30, my housemate Angelo, and from 30 to 40, me and my spouse. Yes? Yes. That's a plot object. That's all it is. That's easy, right? Okay. Now, I'm going to switch over to Keynote. So if you have had RStudio open in another window, you can feel free to close it and not think about it again for the next 10 minutes or so. I know, you're welcome. Okay, here I go. Keynote. Here are the slides. This is an important slide, and in fact, it's important enough that I'm going to put it in Blackboard as a PDF. A great plan for you for Tuesday would be to focus your questions and comments on this slide, because this is going to be the majority of the quiz on Thursday. So again, these are important things. You should put them in Build Your Own Textbook. You should take notes about them. You should stop the video and think about it whenever you need to, et cetera, et cetera. But please do pay attention. All right, so what I have here is a table talking about the types of variables that we use in political science. Most of these we talked about a little bit on the first day of class. So for example, a character variable takes the value words or numbers that you're treating as words. It does not have, you can see in the column CV, this one here, yep. CV here stands for controlled vocabulary. Controlled vocabulary is when there's only a certain number of there's only a certain number of phrases or words you can choose from. So a good example of that is when you're buying something online and you do pull a drop-down menu for state, and you can't choose XZ, right? You can only choose what's there from AL, Alabama through WY, Wyoming. Gosh, I hope I'm right. So controlled vocabulary means there's a limited number of options, but those options can be words or numbers. Okay? Okay. So a character variable does not have that, nor does it have any inherent order or scale. Order just means things go in a particular, order, from best to worst, from biggest to smallest, from nicest to least nice, etc., from liberal to conservative, or from conservative to liberal. These are all things that have some sort of inherent order inside them, even if it's not a kind of neatly numerically measurable order. All right? Character variables don't have that. They don't have controlled vocabulary, as I said a minute ago, and they don't have scale. Scale just means the distance between the categories is the same. And if you don't have order, you definitely can't have scale. Cool? Cool. Okay. So I've also given you a bunch of examples. So there are 3 columns in the middle. A data set on pets, a data set on books, and a data set on students. And you can see in each some potential examples of each kind of variable. So character variable. Next is categorical variable. This is, a type of variable that has a controlled vocabulary but lacks order or scale, right? So you can't put Republican under dog breed. You are limited to things like mixed breed, German Shepherd, etc. These are all things that we get to decide. And in fact, making choices about what your controlled vocabulary includes is going to be a really important part of any survey investigation and of a lot of different political science work. So we'll talk more about it. In any case, categorical variables are not typically numerical. That is, they don't have any order or scale, but they do have a controlled vocabulary, right? So there's a certain number of recognizable genres of books. There's a certain number of majors at Drexel. Yeah? Yeah. Okay. Next, ordinal. These are categories that go in an order. So there is a controlled vocabulary, there is order, but there's no scale. And the one I want to focus on here is 1 to 5 stars on Goodreads. I don't know why I chose Goodreads. I could have chosen Netflix. I could have chosen Yelp, whatever. I could have chosen Lyft. In any case, in these contexts, you're not counting stars. You're categorizing your feelings in a rough order based on a system of 5 stars, right? So 1 to 5 stars on Goodreads is not a count variable, or rather, you shouldn't treat it like a count variable, because you can't talk about a sort of scaled difference between the feelings that go into a 1-star review and the feelings that go into a 2-star review, right? You can't say, for example, a 2-star review requires you to feel exactly twice as good as a 1-star review. That's not a thing. So these are things that go in an order but lack a clear scale. And in political science, we often use these sorts of variables to talk about rough magnitude. So under pet data, you can see approximate dog count, none, few, many, too many. 1 to 5 stars, which is roughly equivalent to terrible, sort of bad, mediocre, good, great, right? Class year goes in an order. Class year is, we could potentially talk about that as the number of years someone has been on campus, but it's also a status depending upon a bunch of other stuff like how many credits did you come in with, right? So really we should be treating variables like that as ordinal rather than as count. Count variables, as the name implies, are things you can count. The number of dogs you have, the number of vet visits those dogs made, the number of books you bought this week, the number of classes you're taking this quarter, etc. Because count variables are numerical, we stop caring about a controlled vocabulary. It's not that there isn't a controlled vocabulary, it's just that the controlled vocabulary is integers. Count variables have order and scale. Order is obvious, right? 0, 1, 2 goes 0, 1, 2 and not 1, 2, 0. And scale should be relatively obvious because 2 dogs is always going to be twice as many dogs as 1 dog. 2 classes, assuming we're not dealing much with the number of credits, is always going to be twice as many classes as 1, and so on. Next, continuous variables. Those can take any real number value, which is to say they don't have to be integers like count variables. They might be bounded. In fact, there are a lot of continuous variables that are bounded. So, for example, your height can't be lower than 0. Really, your height can't be lower than, some tiny baby's height, which is more than 0. But really, where the rubber meets the road, the limit there is 0. And that's common. Or later on in the quarter, we'll talk about a measure from political science called a feeling thermometer. Now, a feeling thermometer is a weird measure because you're asking people subjectively on a scale from 0 to 100 to talk about their feelings toward usually a political figure. So that is bounded in the 0 to 100 space. But people are allowed to say 51.5 if they want. Yeah? Yeah. And consequently, we treat it as a continuous variable, particularly because we often average across multiple people to get a value for some sort of community feeling about something, right? So what is the difference between how African Americans feel about Donald Trump and how white evangelicals feel about Donald Trump? Yeah? Yeah. So a continuous variable has the controlled vocabulary is that it has to be some kind of number. It has both order and scale. Last but not least, and maybe most importantly of all, in the context of political science, is a binary variable. A yes or no, 1 or 0, does not, did not. All of this stuff is susceptible to being measured as a binary variable. And binary variables are so great. They're so great because they are simultaneously categorical and they operate like continuous variables. Mathematically, they reduce to continuous variables. We can talk more about that if you really, really want to, but for now, I'm going to ask you to just trust me. And remember that a binary variable, by meaning 2, is any variable that has only 2 possible values. So, yes or no, does your dog chew furniture? Did you like or dislike the book? Did you pass or fail the class? Or to move into the realm of real political science research, did a civil war start that year in that country or not? Did you vote for Donald Trump or not? Are you a member of the Democratic Party or not? Do you consider yourself, if you had to choose, do you consider yourself more liberal or conservative? These are all examples of binary variables. Binary variables are kind of everywhere in political science research because so much of what we do is about making choices. We will also see plenty of ordinal, count, continuous, and categorical variables. Don't worry, you'll get to see them all. But binary variables are great. I'm a fan. And I think that's the end of what I have to say in this lecture. Now, the syllabus reads, do practice exercises. And here is what I would like you to do for your practice exercise. For your practice exercise, I want you to add a column to this table. So we have pet data, we have book data, we have student data. Your job is to come up with 1 or 2 columns another type of data, right? War data, or macaroni and cheese data, or Philadelphia housing data, or presidential election data, and talk to me about what types of variables would fit in each of the, or sort of what example variables would fit with each type of variable that I've presented here. So that's all by way of getting you to kind of practice thinking through what are the types of data that we collect about different types of things, and how ultimately are we going to use those data in our analyses. Okay, that's it. I'll see you in class on Tuesday. Thursday is a quiz, I want you to remember. And the lecture for Thursday will be quiz review. So never fear. See you soon. Bye bye.